Hello everybody. This video is to show how to compare machine learning algorithms, and we have linear regression, support vector regression, decision tree regression, and random forest regression as algorithms we would like to compare in this video. So as usual, the first thing to do is to load the data. To load the data, we need Pandas library. So import Pandas as PD, and then read the data. So let me call my data as the object. Pandas pd.read CSV. The data is found in my directory E. The folder SL tech docs. Another folder called lake data, and the data set itself is called lake, so lake.csv. So this is the directory where the lake data is found. Excuse me. Let's see what is in my data by typing my data dot describe. So this is what you get. We have these variables. This is our dependent variable for output feature, and the first 6 here, from evapotranspiration to soil moisture. We have the input features or independent variables. So let's prepare the input and the output feature. Input and output features preparation. Input features. Here in this data set we have also time, which has some characters in it, so like the date, time as date. So it's not shown here, but we need to remove it from the variables in order to have our input features. So we have T as well as lake level. So we remove time and lake level. This equal 1, and the remaining variables are our input variables, our input features. So let's see the shape of X dot shape. Let's also see, let's print the first 10 rows. This is what we get. Then let's go to the output feature. So why? We need only lake level. So from my data we take lake level. So y dot shape is going to give us a one-dimensional array of 240 observation for lake level. And then if you go to printing some few, let's say the first 10 rows, also this is what we get. So now we are going to split our data into testing and training. Training and the testing data set. For this we needed to import train underscore test split function. From model from scikit-learn.model selection. Model underscore selection. Import train underscore test underscore split. Excuse me. And then let's split our data. We have x train, x test, y train, y test equal train underscore test underscore split cover x cover y, respectively the input output features, and we have the test size equal, let's say, 20%. And then let's print the respective sizes and see. X train dot shape, x test dot shape, x underscore here, y train dot shape, y test dot shape. So this is what you get. Number of rows, number of variables you have in each of the split data. So the next step is to compare our algorithms. This is the purpose of this video, algorithm comparison. To do that, the first thing we need is to import libraries and functions. Excuse me. Okay, so we import from scikit-learn model. Let's see, we start with linear regression, so linear model, linear model, space here, scikit-learn.linear model, import linear regression. Then we need from scikit-learn dot smv dot support vector machine import svr. Then we need from clear.tree import decision tree regression. Decision tree regressor. Sorry. Then from scikit-learn dot ensemble import random forest regressor. And we need also to import model selection, because we need to have a k-fold and the cross-bar score from it. So from scikit-learn import model underscore selection. Let me run and see. Maybe there are mistakes. Okay, what is that? Say scalar. No module name. Okay, which one? Scalar. Okay, here. Sorry for the typo. Where is that again? Random forest regression. Random forest regression. So I have T here. Okay, good. We need to plot also. So we need to import matplot lib the pyplot splt. Okay, we are good to go to the next step. Done. Okay, perfect. So now we have model preparations. We have models, a list of empty models. Then we have to append to this list our first model, which is linear regression. Linear regression. So two models again, we need to append our support vector regression model SVR. To this we need to append decision tree regressor. So DT, sorry. Decision tree regressor. And then the last one we need to add to append random forest regression. Excuse me. So now we go to the next step to evaluate the models. So here we will be evaluating on the training and the testing data. So model evaluation, on the training data, set. So we have results, empty list, we have names, empty list, names of the models, of course, and the results, the cross validation results. The scoring equal, here I take mean square error. But how to take the mean square error, negative mean square error. So it means that the final result would be taken into absolute value. So now result, names, and scoring. So for name, model, in models, the key fold equal model underscore selection dot key fold. We need a number of splits to be, we take k equal 10 and the random seed take it 30. And the next step is our MSC CV, mean square error, equal model underscore selection, this is the cross validation, dot cross val score model selection dot cross val score. We will have our model, we will have have X train, have Y train, and CV equal k fold scoring equal scoring. Our scoring is the negative mean square error. So this is what you get. The k fold is what you get here. The CV here. Number is 50, 10, random seed 30. So now we are going to append the results. There are two results don't append. msc msc.cv. Going to append to results here. It's empty. This will have to append it. So result.append msc cv, and the names also, two names. You are going to append name, the name of the model. And we'll have our MSc for the training. We need I'm going to take the mean, the standard deviation, the variance is this, the mean, the variance, and the standard deviation. So with 2 decimals, let's say 3 decimals. So this is for the mean, this is for the variance, this column is for the standard deviation. Okay, so what will have name of the model, we will have the MSc, the mean of it. So MSc underscore CV dot mean, then MSc underscore CV dot var for variance, and MSc underscore CV dot stv. And finally we'll print our MSc. It's wrong. Oh, random state instead of random seeds. Random state. Mess up things here. So random state. So I'm sorry about that. I set the seed to 30 and say the random state equals seed, and now I change. So this is what we get here for the training. So as I said, we need to take these values in the first column here. We need to take it as in an absolute value, because I put here the negative mean square, so we have to take it positively. And this is the variance, and the third column here is the standard deviation. So obviously, which one is better is random forest. Random forest is better than the others. If you have to rank them, you start with random forest, then linear regression, then support vector regression, the last one is decision tree. So we are going to plot these results in a box plot. Plotting the algorithm comparison in a box plot. So we have figure equal to PLT figures, PLT dot figure. We have we need a subtitle, so fig dot subtitle. In the subtitle we write algorithm comparison on the training data. Algorithm comparison on the training data set. Then we have AX equal, we need now the subplot. So the fig dot add, and we add a subplot 111. And this is our subplot already. Excuse me. Then we need the box plot now. So plt dot box plot of what, of the results. Okay, and then we needed to set the X tick labels. For the names. So we have here our MSCs. We have to take them positively, and we have on the x-axis the name of the algorithms, the models. So which one performs better? Random forest is around here. It's followed by linear regression. And then we have spot vector regression in the decision tree. So algorithm comparison on the training data set. And need a plt.show okay. So next step is on the testing data. Model evaluation on the testing data. Set. You need to copy this. I generally don't like copy and paste, but for the sake of time, it's really repeating the same thing over. So let's do it that way. What we need to change here is test. Instead of X train, we change the X test and Y train, Y test. Everything else stay the same. Or if you want to, we can add the result test here, the result underscore test, to make the difference. Because the first one was result train. So yep, that's all. thing. So let me leave it that way. So since we change excess in y test, it's going to give us other result. So this is what you get for the testing data. On the testing data, which one performs better? It's still the same thing. Okay, let's have two decimals. I'm going to change the first one also into two decimals. It's going to round, so okay, we have a random forest and then linear regression. Okay, do the same thing. Let's change this one also to decimals. Okay, 11, 14, 15, 17. Okay, for the box plot, still the same thing. We copy here. We first run this one, and then here we change on the testing data set. Or if you want to, as I said, you write test here, and then you plot results test. So you first run this. Then we run the plots. What went wrong? Did you run this? Okay, result test. Okay. Okay, good. So this is on the testing data. So which one performs better here? Taking absolute value, we still have a random forest, followed by linear regression, then support vector regression and decision tree. Although the values are not the same on training and testing data, but the general pattern is the same. For instance, you take 0.22 for linear regression. On testing data, we have on training 0.14. The first one for training random forest is 0.11. On training data and testing data, random forest equal 0.22, so almost the double. And support vector regression, so it's double, not almost double. 0.11, 0.22 is double. So support vector regression on tested data is 24, and the training is 0.15. Okay, difference of 0.9. So this is the end of the video. Thank you for watching. I hope it will help you to compare your algorithms when you are working on your project or your paper or anything you are doing in machine learning. So thank you very much for watching.